there any questions, things we need to address before we move on to what we're supposed to do today?
Ma'am?
Yes.
So last week, when we were doing the exercise, I think it was exercise 3, my digits were a bit off for some of the answers.
Okay.
And I still don't get why it was that way.
I would have to see how you typed it in on the calculator, because that is the only reason I can think of that they might be different, because when I worked it out, that is the value that you're supposed to get.
Okay, can I send it to you after class on Teams?
Yes, yes, you
Okay.
may.
Okay,
All right. Any other questions, comments? Hey, I hope you remember that the assignment is due on the 30th, just a few days from now. It is not an individual assignment, so no individual assignments will be accepted. You must be in a group with at least 2 other people. So 3 is the minimum and 6 is the maximum. Don't allow people to be in your group and they haven't done anything or you have done all the work. That's not fair, but it's your choice. I wouldn't want anybody who didn't do anything to be part of my group. You'll notice that there are some topics, I'm sure you have noticed already, there are topics in assignment that we haven't covered in class. That doesn't mean you have to wait for us to cover them in class. That is for you to research so that when we are doing it in class, you have a better understanding. So even if we haven't done something in class, but it's part of the assignment, then that means it is research for you to go and learn that and then answer the questions. Okay, so today it shouldn't be a very
sorry,
long.
ma'am, I have a question.
Yes.
Sorry, I just wanted to find out from you the format that we must send the assignment in. Do you want it typed, or should we extract the questions from each member and then put it in one assignment page?
Let me just take a look over here. Okay, since it's not specific, you may type it. It's really up to you. Okay, so you may type it if you wish. You don't have to answer each question 6 times because there's 6 of you, just the final one that you all agree on. I think that's what you are asking. I'm not sure, but you may type it as long as I get a PDF at the end and not a Word document.
Okay, no problem. We'll do that. Thank you, ma'am.
Right. Okay, anything else? Okay, then we're good. So like I was saying today, I want us to finish off on the sampling distribution. So we are going to do the last 2 questions in exercise 3 that I gave you sometime last week. So it's available here on Teams. You just scroll up, you'll see it. And for today's class, I've also uploaded another exercise or worksheet. It's a little bit shorter than the previous ones we've done, but we will be doing some of those questions as well. Then on Wednesday, we should start with a confidence interval, which I'm sure will be very easy because you guys will have already done the assignment, so you know exactly what I will be talking about. All right, so let us look at number 6 in the exercise where we left off last week. Let me just, okay, so this is exercise 3. It is dated the 19th of October. So question number 6 says the amounts of electricity bills for all households in a particular city have an approximately normal distribution with a mean of $140 and a standard deviation of $30. Find the probability that the mean amount of electricity bills for a random sample of 75 households selected from the city will be between 132 and 136. So again, whenever you're given questions like this, what you should do is write down the information that you have. So we start with mu. Okay, so we are told that mu is equal to $140. That is the mean for the population. Then we are told that the standard deviation sigma is equal to $30. So I can just write it as 30. We are told that we are sampling 75 households. So small n is equal to 75. Now the question is, what is the probability that your average for the sample, which is x bar, is between 132 and 136. So this is what we are asked to work out. So I've listed all my information over here. I write down the question in a mathematical way or statistical way, so I know exactly what I'm looking for. Now, when you have your x bar over here, the first thing you need to do is you need to standardize. So we know how to standardize. You will subtract mu, and then you'll divide by sigma divided by the square root of n. Okay, so you'll standardize this one, standardize that one, and when you standardize x bar, you will get z in the middle. So what this is going to look like, this is the probability. Then I have 132 minus my mu, which is 140. Then I divide by sigma, which is 30. And sigma is divided by the square root of n, and my n is 75. Okay, less than or equal to. Now I don't need to show the standardizing of x bar. You can write it, the formula x bar minus mu over sigma over the square root of n, it's fine. But we know that when we do that, we are just going to end up with z. Then we do the same thing on the right hand side. So I have 136 minus 140 over 30 over the square root of 75. We close our brackets. So can you work out these values over here and then tell me what you get? So if you were to type this on your calculator, you should brackets over there, and then this is represented by a division. Okay, unless you have one of those calculators that can type it in exactly the way it is. So can somebody tell me what they get when they work that out?
Ma'am, can you hear me?
Yes.
I got negative 2.31 rounded off.
Okay, negative 2.31. Anybody else get the same thing or something different? Okay, I also got negative 2.31. So I hope that is what the rest of you got, even though you're quiet. So please feel free, join in. That's how I know that you understand what is happening. Okay, so in the middle, I have Z. And then on the right-hand side, can somebody tell me what you got? 136 minus 140 all over 30 divided by the square root of 75.
May I answer?
Yes, go ahead.
I got negative 1.15.
Okay, he says negative 1.15. Anybody else who got the same thing or something different?
Same thing.
Okay. All right, so that is also what I got. This is negative 1.15. Okay, so now that we have our Z scores over there, it's always good to draw a sketch and picture what it is you will be reading from your normal table. So if I draw remember we okay, that's supposed to be a 0 right there in the middle. And what we know about the normal table is that the left-hand side and the right-hand side are exactly equal. So if this was a piece of paper and I fold it along this line, this would fall perfectly on this side of the graph. So the area this side is exactly equal to the area that side. So you can think of it as a mirror image of the other side. Okay, so it is symmetric. So this is a line of symmetry. So now we need to represent this negative 2.31 to negative 1.15. Now we know negative 2.31 is somewhere over there, and then negative 1.15 is somewhere over here. So the area we're looking for is actually this area over there. So this is negative 2.31, and this is negative 1.15. Okay, so this is the area that we are looking for between negative 2.31 and negative 1.15. Then what I did this time is I downloaded the table that is always provided, because this is the table that you will always be given. So I looked at past exam papers and I see that it is almost always, in fact, it's always the papers that I've seen, it is always the standard normal cumulative table. So this is what it looks like. It reads values from negative 3.4. It goes all the way to 0, and then it continues from 0 all the way to 3.4. So this one makes our lives so much easier. Okay, so you can read from any negative value, negative 3.4 up until positive 3.4. So you can see here, if the value we're looking for is 3.49, it's almost equal to 1. So that's almost the entire normal table. And if we want to read values from less than negative 3.4, you can see that it is almost equal to 0. Okay, so now that we know what table we are going to use, we need to see how we can derive what we want from the table that we are given. So the table that we are given, Okay, so the table that we are given reads off values like that. So it reads off values like this, and then it keeps reading going this way. So if I pick a point over here, the table will give me the area over there. So if I pick a point over here, the table gives me this area over there. So it always gives you the area to the left of that point. But like I said, what we are looking for is this area between negative 2.31 and negative 1.15. And then 0 is always right there in the middle. So here we don't need to show it. So what we're looking for is this area that I've shaded over there. Now, what we can do is we can work out this area that I've shaded here by working out the area from negative 1.15 going all the way that way. And then from the table, we can also read the area on the left of negative 2.3 going all the way that way. So if we were to subtract these two, we would end up with this area over here, which is what we're looking for, isn't it? Is that right? Or does that make sense?
That is correct, ma'am.
Okay, so we know our table gives us the area to the left of whatever point we want. So if we're looking for the area between 2 points, you can find the areas to the left of both of the points. And if you forget which one should subtract which, just say the bigger one. Whichever area is the bigger one, subtract the smaller one from that. Okay, so what we are going to do is we are going to read the probability that Z is less than or equal to negative 1.15, which is this area all the way to infinity. So this line over there. And then from that area, I'm going to subtract the area to the left of negative 2.31. So this is the probability that Z is less than negative 2.31. So that's what I'm doing. So here was just a representation of what I'm doing. Now I'm actually working out the values. So if you forget again,
Ma'am?
yeah.
Just a quick question. You say you downloaded the standard Z table. I made use of the table that was provided on the study guide. And then I took a quick look at your previous screen compared to mine, and I'm off by 0.003. Will that be a problem?
0.003. No, it will not, but I think we should end up with the same answers.
Like roughly the same amount.
Yeah, almost exactly.
Okay, what would you consider roughly close? Because if I get, let's say, for example, 11.50 and you get, let's say, 11.45, would my answer still be incorrect?
Ooh, 4, 5, and 50, those are quite far apart. I'm thinking maybe 11.50, maybe 11.49, 11.51. I would say these three are close, but 4, 5, that seems a little too far. But it is possible. But you know what's going to happen? In the test, we will give you a table. So we expect you to use the table that is provided, not your own table. So it is possible to get different answers from different tables, but when we give you the table, everybody will get the same answers.
Okay, thank you.
All right. Okay, so let us now read off these values from our normal table. So we're looking for the probability that Z is less than or equal to negative 1.15. So I'm going to go to my normal table now. Okay, so we're looking for negative 1.15. So we scroll down and then negative 1.1. Remember, this is the Z, or these are the Z values. So negative 1.1, so this is the row that I'm going to be using all the way across. Then the first one is the probability for negative 1.10, then negative 1.11, negative 1.11, yes, then negative 1.11, 1, 2, 1, 3, 1, 4, and 1, 5. That is the value that we get. So this one over here, let me see if I can highlight it. Okay, no, because it's not in the notes. Okay, so the value that I get is 0.1253. So then I write it down. So this is 0.1251. Okay, then I read this one off my table, so negative 2.31. So I go back to my table. Then I need to scroll up, negative 2.31. So here's negative 2.3. Then this is 0.30, 0.31. So this is the value that I am going to take. The probability that Z is less than or equal to negative 2.31 is this one here, 0.0104. So I write that down. So this is minus 0.0104. Okay, this is an easy subtraction to do, and I got 0.1147. Okay, so that's what I got. So very simple to do. And then remember, if you get a word problem, you must also answer it in words. So you might say, okay, so you might say something like the probability that the mean amount of electricity is between $132 and $136 is 11.47%. So I've converted the 0.1147 as a percentage. Now to do that, all I did was multiply the 0.1147 by 100. So if you multiply this by 100, then you can add a percentage sign at the end. So this is exactly what I did, and that is why this is my answer. Are we fine with that one?
Yes, ma'am. It seems like I might have misread, but my answers is identical to yours.
Okay.
I do have a question though. If the mean of the amount is $140 and we have a variance of $30, I would have assumed that the answer would have been a higher percentage. But is the reason the percentage is so low is because the probability that we are looking at is very specific between 132 and 136?
Okay. Usually you would expect most of the data to be around the mean, and it should be, if it's a range that contains the mean, you would expect most of the data to be around that area. But if you look at this one, 132 to 134, the mean is outside of that. So that's why it's quite small compared to if it was maybe 141 to 142, even though the probability, the standard deviation is a little bit bigger, but because it's, for example, let me just write it. So you can see our mean is over here. This is 140, but we're looking at a range somewhere here. So we have 132 to 136. So the range we're looking at doesn't even contain the mean. And usually what happens is most of the data is concentrated around there. So that might explain why the probability is a little bit low.
Okay, thank you, ma'am. It makes sense.
Okay, let's do number 7. Number 7, let me just read it. Number 7 says, suppose that the mean intelligence of 1,800 high school boys are known to be normally distributed with a mean of 200. So we are told that mu is equal to 200, which is very high, and a standard deviation, sigma, which is equal to 16. Then a sample of 36, that means our n is equal to 36, is drawn from this population. So this 1,800 is the population, okay? Because it's a school, you can obviously count how many they are in there. It's not very big. So a sample is drawn from the population of 1,800 high school boys. Now the first question says, how many school boys have the mean intelligence of more than 195? Okay, so here I need you guys to help me out. Tell me, how do we do this one? Because it seems a little bit different than what we have been doing so far. So far, we have been finding the probability that our sample mean is between a specific range. Now, this one is asking how many boys have a mean intelligence of more than 195. How do we do this one?
Isn't it the same process, but instead of having two, what do you call this? A specific range, we are going from the probability of the mean x or x bar greater than 195.
Okay, let me write down what you are saying. Okay, so you're saying the probability that x bar is greater than 195. Okay, so you're saying we need to work this out. Is that right?
Yes, ma'am.
Okay, then after we've worked it out, then what? Because the question says how
Sorry,
many
ma'am.
boys?
Yeah.
Yeah.
Oh, no, sorry. Continue. I was actually going back to the question.
Okay, the question says, oh, are you, go ahead.
No. You can continue. I'm just rereading the question again. How many schoolboys have the mean intelligence of more than 195? So if we work it out normally in terms of the scale, isn't it now from from 195 onwards towards infinity?
Yes.
But isn't that answering the question already, or am I missing something?
No, that is not answering the question, because if you look at this previous question, if you look at how I answered it, I say the probability that, I didn't say there are 132 households that, or there's this many households. I didn't use any numbers. I gave a probability.
Oh, I got it.
So
Then
this
the
question
answer
is
that we get,
number.
the answer that we get would be the percentage of that 1,800.
And then what do we do with that percentage to get the number of boys? Okay, or maybe let's do everything step by step. The first thing is, right, we need to work out this probability. So we already know how to do this. If what we need to do is we need to standardize. So the way to standardize, we will subtract mu from 195 and then we'll divide by sigma over the square root of n. So this is the probability that Z, so it becomes Z after I have standardized. This is greater than 195. We said our mu is equal to 200. And then we divide this by sigma, which is 16, over the square root of n. N over here is 36. Okay, can somebody tell me what they get on the calculator when they work this out?
May I answer, or should we give a chance to someone else?
Hold on. Let's hear from somebody else, please. I'm sure you're not the only one here.
Okay.
Anybody else in class today? Please give us an answer as well. I want to hear your voices.
I got negative 1.88.
Okay. Anybody else? I'll just write that
I got
down.
negative 1.86.
Okay. I got negative 1.88. Okay, so John, check what you check that again, because I got this, which is the same as what's your name? The lady who just answered.
Non-clear.
Nontle.
Yes.
Okay. All right. So me and Nontle got the same thing. So we can just confirm if what we did is correct. So
You're correct.
okay.
I made a mistake.
So such things can happen if when you work these out, you split it into several steps. So if you're rounding off as you go, then you might find that your answer over here is not going to be correct. So just be careful when doing that. Okay, so now we know our z-score. We go to the table. So the table is going to appear just now, and I want somebody to read from the table and tell me what my z-score is. And somebody, not John, not Nontle, please, somebody else. The Z table is over here. Can you tell me, sorry, the normal table is here. Can you tell me what the Z score for negative 1.88 is going to be? Or should we sketch it? Let me just draw a sketch very quickly. So this is what we are looking for. So negative 1.
Thank you, Ronnie.
Is going to be here. So what we're looking for is this area over there, going that way. So first thing, I will ask somebody to please look at the normal table that I have over here. I'm sure you can see my values and tell me what is the Z value for negative 1.88.
0.301.
0.301. So you say this one over here. Okay, that is very good. So again, we go to our Z score. This is negative 1.8, negative 1.8, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that is correct. This is our value. So I will just take note of that. So from the table, we got, let me use a different color because that is not the actual answer that we're looking for. So from the table, we got 0.0301. So can you tell me, is this the probability that we're looking for, or do we need to do some more calculations to get the actual probability? So I wrote it in red, not to say it's not and not to say that it is. I'm just asking. So it may be the answer. It also might not be. So I want you guys to tell me, is this the probability that I'm looking for?
Ma'am.
Yeah.
Like we discussed before, it's not the complete answer yet because we
Okay.
need to work out this percentage and work it out from the 1,800 high school boys so we can get a specific amount to answer the question.
Okay, so okay, we're not there yet with the number of boys. We're still solving this one here. The probability that Z is greater than or equal to that. We read this from the table. Now I'm asking, is this the probability of this? Are these two equal? That's what I'm asking. Because after we get the probability, we still need to work out the number of boys. So you're right there, we're not done. But is this value here the probability that Z is greater than 0.88? That's my question. Okay, so again, whenever you get an answer, always think, okay, we know that these are very highly intelligent boys. They have an IQ of 200. So I'm asking, what is the probability that the average IQ is greater than 195? And this is like 3%. So I don't know. Is this the value of that?
No, I think I'm getting you. I understand you, or getting you at this point. No, aren't we supposed to take 1 minus this answer?
Exactly, that is what we are supposed to do. Now remember, our normal table gives us this reading. Because it's cumulative, this 0.031 corresponds to this area over there. But if you look at what I've drawn over there, these two are not the same. Okay, so this 0.031, which I got from the table, is giving me this smaller area over there. But that's not the area that I want. The area that I want is this one that I've shaded in black. Now we know that the entire area of under the normal curve is equal to 1. So if this area is 0.031, then to get this one in black over here, I must say 1 minus this small area over there. Okay, so that's what I still need to do. So I will say the probability that Z is greater than or equal to, just greater than, negative 1.88. This is equal to 1 minus the value that we read from the table, which is 0.0301. And when you work this out, hopefully you get the same thing that I did, which is 0.9699. Okay, now we know the probability that a schoolboy has an IQ of greater than 195. So to work out the number of boys, since we know the percentage, so this one you can also write it as 96.99%. So to work out the number of boys that have that IQ greater than 195, all we'll need to do is multiply the percentage by the total number of boys in the school. So we will say 96.99% of 1,800. So this is just 96.99 divided by 100, and then we multiply this by 1800. So when you work this out, you should get, what I got is 1,745.8. But obviously we can't have 0.8 of a person, so this one we can round it up. So this is approximately equal to 1746. And again, because this is a word problem, it was given to you as a word problem, you should answer your question in words. So you can say 46 schoolboys have say an IQ of 195 or higher. So again, you can phrase it a little bit differently, but the gist of what we are saying must be the same. So I want to see this number over here, and it must be stated in words. So I'll look at all your calculations. They must be done correctly, and then finally answer. Okay. Okay, then let's look at B, if that one is fine. This is B. Now B, the question says, what is the probability that the mean intelligence is between 193 and 207? Okay, now you look at this one. The average is 200, and 200 is between 193 and 207. So we are expecting a higher percentage than if we're looking at an interval that did not contain the mean at all. Okay, so what we're looking for is the probability that X bar is between 193 and 207. Okay, so now that we know what we're looking for, we stated it in as we've written it as a mathematical expression. All we need to do is standardize this 193 and this 207. So to standardize is not very difficult. We'll say this is the probability that 193 minus 200 over sigma is 16 over the square root of n. N is 36. Okay, and then we need to standardize X bar as well. And when we do that, we get Z. Then on the right hand side, we do the same thing. We have 207 minus 200 over 16 over the square root of 36. Okay, so can somebody work that out and let me know what you get?
Is anyone going to answer?
Okay, do we have any answers, please? Don't be shy. This is how you learn. Okay, so you know if what you're doing is correct, if you're on the right path or not.
Negative 2.625.
2.265.
25.
No, I don't think that's right. Well, that's not what I got. Negative 2 point, you said negative 2.2.
Negative 2.63. Negative
Okay.
2.65.
Okay. Okay, so if you work this out, I got is negative 2.63 Z, and on the right hand side I also got negative 2.63. Okay, so here you can see
Ma'am,
is
isn't it
that right?
supposed to be a positive 2.63?
Yes, it should be positive. Okay, and you can see that they are the same except that one is positive and the other one is negative. And okay, and it makes sense because in the numerator over here I have negative 7, and in the numerator over here I have positive 7. So these two should be exactly the same except one is negative and the other one is positive. Okay, so now that I have my Z scores, next thing I need to do is maybe sketch and see what I'm looking for. So this is, okay. So I'm going to sketch, it's not much better. Okay, so I have negative 2.3 over there and positive 2.3 over there. So this is negative 2, what is happening? 2.63, and this one is positive 2.63. So this is the area that I am looking for. Now remember the data that we get from our table. Our table gives us readings to the left of any value. So if I have negative 2.6 over there, it's going to give me this area over there. And if I were to read the value of positive 2.63, it's going to give me this entire area over there. But I want this area over there. So can somebody tell me how I would work out that area? So let me use a different color. So here, just the orange area or the black area over there. So you can see I have the area shaded in blue and orange, the area shaded in red and blue. Now I just want this orange area over there, which is the same as that one. Can somebody explain to everybody how you would work that out, knowing the data that we get from our table?
May I answer?
Yes, please.
I think when we get the value for 2.63 and for negative 2.63, then we subtract what we got.
Okay, very good. And if you ever wish bigger as the smaller one, so that is very good. So you can see that this area goes all the way that way, and then this area goes from there. And if we're looking for this area here, we just say bigger one minus the smaller one. That will give us the area in the middle, which we are looking for. So very good. Now let's go to our table. And again, I want you guys to read this. So we'll start with negative 2.63. So I'll just scroll up. So can somebody tell me what is the Z score for or what is the probability that Z is less than or equal to 6.3. So I hope you can see my table and it's clear enough for you guys to read off of it. Let me zoom in just a bit.
Ma'am,
Yeah,
0.0044.
4. Is that right?
Oh,
I got
0.0043. Sorry.
Exactly. Okay, so what we do is, these are our Z values, so we go to, so what we do is, okay, so what we do is we are looking for negative 2.63. So we go to this column and look for negative 2.6. There it is. Then remember the first one is negative 2.60. 2.61, 2.62, then 2.63. This is the one that we are looking for. So the probability that Z is less than or equal to negative 2.63 is 0.00. So be careful with that. So now we write it down. So this probability over here, this is 0.0043. Now we need to work out this one over here from our table. So we go back to our table. So this table has negatives all the way up to 0. Then we scroll down, we continue. So it continues 0 and the positive values. So we look for 2.63. So it's going to get clear just now. Okay, so we have 2.60, 2.61, 2.62, 2.63. So this is the value, 0.9953. Is it 5.3 or 5.7?
It's 5.7, ma'am.
Okay. Okay, so now we have our two values, then we can write this nicely. So the probability that Z is between negative 2.63. Okay, let me just go to another page. So the probability that Z is between negative 2.63 and positive 2.63. So I'm going to show my calculation. So it was 0.9957. And then I subtract, what was the other one? 0.0043. 0.0043. So this you just do on your calculator. And I got 0.9957. 0.14, which is the same as 99.14%. And then as usual, we want to write this as a statement and answers the question. You can say the probability that the mean intelligence is between 193 and 207 is 99.14%. So again, feel free to use your own words, but what we are saying should be the same. Do we have any questions? Okay, it seems everybody is fine. Then we will move on to this theorem over here. Now this is just something that you need to know. It says it's called the central limit theorem. This says that if the population is not normal, so far we've been dealing with normally distributed populations. You know what that means? It means when we draw a histogram of the data, it looks something like that. So most people or most elements are right here in the middle. There are very few that are in the extremes. So you can think of this, like I said, with height. Most people are around here. There are very few very short people and very few very tall people. So most people are in that range. So this is like normally distributed. But what happens is that even if a population is distributed, we can apply the central limit theorem that says that samples drawn from the population will be approximately normal as long as the sample size is large enough. And that means you have a sample size of 30 or more. So even if your population is not normally distributed, as long as you pick sample size that is 30 or more, then you can still apply these principles that we have been doing. Okay, so this is just what it says. Good theorem to take note of. Then we move on to sampling distribution for the sample proportion. So remember we had statistics and parameters. So we use our statistics to estimate our parameters. So we've been using the sample mean along with the population mean. Now we're going to do something similar with the proportion, and we say the population proportion pi. So we use the letter pi for the population. So pi is a parameter. It represents a proportion of the population, and the sample proportion we use p, or sometimes you will see it's written as p hat. Okay, so in the same way that we were using x bar and mu, we will do the same thing with p and pi. Okay, so we're going to be doing something different, something similar. We will be standardizing our p-value so that we can read the data from the table. Okay, so the population proportion is used as a central location measure when the random variable under study is qualitative and the data is categorical. So you have nominal and ordinal. So remember nominal data, which you must have done last semester. This is data that you can't really rank it. So it's in the name. So it's things like male and female. Those are nominal variables. And then ordinal, there is some order to it. okay, but there is categories within that order. So age can be made ordinal or categorical in that you can say age from 0 to 5, from 5 to 10, then 10 to 15, and so on. So you can make categories of that. So with that age, it is ordinal because there is an order that you follow, but nominal, there's no order, it's just a category, whether it's male or female. So we use proportions, or we calculate, first of all, we calculate the sample proportion in this manner. So we say this is just x over n. So if, for example, I say that there are 6 out of 20 in your sample, then this is your proportion. So you have 6 elements in the sample out of the total. So it's just a proportion or portion of your sample. Okay, so this can also be expressed as a percentage. So sometimes the proportion is given as a fraction like this, or as a percentage, even a decimal. You can also work with it like that. So here are some other, or the same here, gender, which I mentioned already. So a sample statistic, proportion of males or females in a sample of students. Then another random variables, mobile phone brand preference. Then you look at the proportion of mobile phone users who prefer Android as opposed to iPhone. Okay, so here you're just looking at proportions. Those who want this, those who want that, and so on. But what we will be doing is pretty much the same thing we've been doing with xbar. I will ask you what is the probability that the proportion is within a given range. What you need to do is you need to standardize, then you read from the Z table, and then you answer with a statement. Okay. Okay, so here the sample proportion is related to its population proportion in exactly the same way as X. So this is just what I was explaining, and it can be described by the sampling distribution of the sample proportion. Okay, the sample proportion P is itself a random variable as the values of each sample vary from sample to sample. Okay, now what this means is if you have a proportion that you are working out for a sample, because you can pick different samples from your population, each sample has its own proportion. So you'll get different values depending on whatever sample you pick. So it is a random variable that depends on the sample that you pick. Then the variance is given by this formula P Q over N. Q is just 1 minus P. So if you know what P is, to work out Q, you say 1 minus P. And here, P is a fraction, which is less than 1. And to get Q, you just say 1 minus P. And obviously, P and Q add up to 1. So if this is the variance, then the standard deviation is the square root of that. Okay, so when we are standardizing, this is what we are going to be doing. So remember when we were standardizing x bar, we said x bar minus mu. Now we have P with its parameter. Here I had x bar with its parameter. Its parameter was mu. So instead of mu, I have pi over here. Then I divided by the standard error. The standard error of x bar was sigma over the square root of n. So I had sigma over the square root of n. This was my standard error for x bar. But now I'm dealing with proportion, so I use the standard error. So this is pi multiplied by 1 minus pi. So you can see it looks just like this one, where it's the proportion of the sample multiplied by 1 minus the proportion of the sample divided by n. So it's the proportion of the population multiplied by 1 minus the proportion of the population and then divided by n. Okay, so this is just another formula that we need to make use of. We are going to do it in exactly the same way that we have been doing this one here. Okay, so before we look at some questions, does anybody have anything they would like clarity on, or can we move on? Okay, so like I said, I have put exercise 4 in Teams. It's just under the meeting ribbon tab there, so you can download it and then follow with me, or download it after and then go through what I have done. Now the first question, I will read it to you. So the first question says, time spent using email per session is normally distributed with mu equals to 8 and sigma equal to 2 minutes. If random samples of 25 sessions were selected, what is the probability that the sample mean of time spent would be between 7.8 and 8.2, and then B, what is the probability that the sample mean of time spent would be greater than 8.5? Now this question 1, I'm not going to do it because it is on the sampling distribution of xbar, so you guys will do that one. So it's exactly like the previous questions that we have been doing. So it's not on proportion, it is on the mean. So you should know how to do that one. So we don't have too much time, so I only want to work on the questions with proportion. So doing that, I look at number 2. Number 2 says the Namibian poll found that for those Namibians who have lost weight, 31% believe the most effective strategy involved exercise. What is the probability that from a random sample of 300 Namibians, the sample proportion falls between 29% and 33%? Okay, so again, whenever you have these questions, what you need to do is write down the information that you are given. Now we are told that the Namibian polled all the Namibians who have lost weight, and 31% of them say that exercise was the main thing, or something like that. So our pi is equal to 31%, and this is the same as 0.31. Okay, is that fine? Are we okay? Or am I alone again?
Yes, ma'am.
Okay.
No, we're with you.
Okay, so this is our population proportion. Now, what are we asked to do? We are asked to find the probability that from the random sample of 300 Namibians, the sample proportion falls between 29 and 30%. So we have to work out this 29%, and then we put our statistic, and 33%. Okay, so this is what we have to work out. So we are also told what small n is. And let me just add it over here. So we know that N is 300. So we sample 300 from the population. So this 31% is the population parameter. So all the Namibians that have lost weight, 31% agree that it's because of exercise. Then from all of them who've lost weight, we ask 300 of them, and now we want to work out what is the probability that we will get between 29 and 33% from our 300 who say that exercise is the main thing. So just like when we were using xbar, we need to standardize, but this time we're not standardizing with mu and sigma over square root of n. This is how we standardize it. So we'll say p minus mu, minus pi. So pi is 0.31, and then we divide by pi over 1 minus pi over the square root of n. So let us do that. So this is the probability. So big brackets over here. So now I'm standardizing. So instead of 29%, I write 0.29. Then I subtract pi. Pi was 0.31. And then I divide by a big square root. Everything in the denominator is under my square root. Okay. Then I say pi 0.31. I multiply that by 1 minus 0.31. And then I divide this by n, which is 300. Now, when you're writing it, it's very important that everything in the denominator is under the square root. So that's why I have a big square root over here. Okay, and these two are multiplying, and then I'm dividing by 300. Okay, then in the middle, I have standardized my P. When I standardize P, it also becomes Z. Okay, then this is less than or equal to, so I don't have space over here. So what goes over here, I'm just going to write it down there. But you have space in your books, so you can write it in one line. So I standardize the one that I have on the right hand side. So I have 0.33 minus 0.31 divided by a big square root 0.31 multiplied by 1 minus 0.31, and then I divide by 300, and then I close my big bracket. So as always, can you guys work out what I have here on the left, and then let me know what you got? So be careful with the square root. All of this has to be under the square root. If you do not type it incorrectly and it's only the numerator of the denominator, or this part over here, that is under the square root, your answer will be different. So type it incorrectly and let me know what you get.
Hi, ma'am. Do we also need to give the answer in in 2 decimal places?
Yes, because we are going to read from the normal table, and our normal table goes up to 3 decimal places. Sorry, 2 decimal places. So you should also give yours in 2 decimal places.
Okay. Can I give my answer, or should we wait?
Okay, let's give 1 more minute, then you can give yours. Okay, John, go ahead. What did you get?
I got negative 0.76 rounded off.
That's a little bit different from me. Did you do it in steps where you worked
Yeah,
out
I
the...
did it in steps.
Okay. All right, that's why.
Otherwise I
But
can
you
try
didn't round off
again.
anything?
No, nothing at all. I just use whatever divided by answer, which, yeah, I use from my Casio.
Okay, that should give us the same thing, but I'm getting negative 0.75.
Okay, I'm gonna try again.
Okay, they are pretty close, and I just typed mine in without working them out in steps. 0.29. Okay, then this is Z. Then on the right hand side, you should get the same thing, 0.75. This is what I got. Maybe I'm wrong, but you can check.
No, you're correct. I redid it again and I got negative 0.749, which is 0.75, yeah.
Okay, all right. So guys, be careful when you are working this out, especially if you're doing it in steps. Avoid rounding off too early, because here with the square root, most of the time it's not going to be a whole number, so it'll have a lot of decimals. And if you round this off, it's going to affect this. And this last digit is quite important when you're reading from your normal table. So if this 5, you put a 4 there or you put a 6 there, it's going to affect your final answer. Okay, so now that we have this, you guys already know how to read this from the table. So just a visual representation of what we're looking for. Here we have negative 0.75, and over here we have 0.75. So we're looking for the area in the middle. Then again, we will say, because our table gives us the areas to the left of whatever point we have, I could work out the area from 0.5 going down, then the area from negative 0.5 going down, and then just a bigger one minus the smaller one. So let me do that. This is the probability that 0.7 negative, that's negative over there, is less than or equal to Z, is less than or equal to 0.75. Okay, so I'm going to work out the bigger one over here. So I go to my table. So I look for positive 0.75. So I have 0.7, 70, 71, 72, 73, 74, 75. So the Z score for 0.75 is 0.7734. So this is 0.7734, and then I will subtract the Z score for this negative 0.75. So again, I go to my table. Now this part of the table only has the positive values. I want the negative ones, so I go up on my table, and I'm looking for negative 0.75. Okay, negative 0.7, 70, 71, 72, 73, 74, 75. So that is 0.2266. Zero point 2266. Okay, then I work this out on my calculator. 0.7734 minus 0.2266, and I am getting 0.5463. Okay, so it's 0.5463. 6.8, sorry, not 6.3, 6.8. Then again, because this is a word problem, you should answer your question with a statement. So you would say the probability that the sample proportion, is that even right? Proportion is between, there's an EN, is between which values? In the question, it was 29% and 33% is 54.68%. Okay, so that is how you would answer that question. So like I said, I have uploaded exercise 4 just below the link to this class. So there's 2 more questions that I would like for you guys to do. And I'm sure you can see there isn't too much difference between what we're doing with the population, with the proportion, compared to what we were doing with the mean. So before we go, are there any questions anybody wants to ask? Or are you guys fine?
I'm okay.
Okay.
Yes.
All right. So if you guys are fine, I will see you guys on Wednesday, and then we will conclude this section and then start on confidence intervals. Okay, so have a good evening. Enjoy the rest of your classes. I will see you guys on Wednesday.
Thank you, ma'am. Enjoy your evening.
Thank you, ma'am.
Thank you.